Tangent line and secant line. So can you distinguish the difference between tangent line and secant line? Yes, the tangent line case, you have any objective here, then it only pass through exactly one point. So that's tangent line. But secant line case, the line passing through like more than one point. So normally it's like 2 points here. So even function case also, I can distinguish tangent and secant case here. So whenever we have a curve like this exists here, then tangent means looks like this, secant means something like this. So likewise, tangent line means the line intersects with any curve, any object at exactly one point. But secant line case, it passing through, so intersect more than one point. So now we think about the secant line first, and then we go back to tangent line. For secant line case, because it has two different points, in this point here, you can indicate this one is x1 and then y1, and this is x2 and y2 here. Then can you describe how to find the slope of the secant line? Yes, exactly. So m equal to y2 minus y1 over x2 minus x1. So that's the slope of secant line here. From now on, I want to play with the slope formula a little bit more. Good? So let's think about the function notation. Function notation means, or functional notation, which is if we have y equal to maybe the linear function like this, then you can rewrite this f(x) equal to mx plus b like that. Or any other function y equal to maybe axm plus a first xm minus 1 plus like this, then the functional notation indicate fx equal to axm plus a1xm minus 1 plus something like this. So functional notation indicate fx, that is actually output y value. So you can think fx equal to y, that's the meaning here. Then what is the reason almost mathematician, they prefer using functional notation instead of y? The reason is functional notation indicate input value and output value at a one notation. When you look at this formula carefully, then this is our input value. This whole thing indicate output value here. Therefore, fa means what's the y at x equal to a. That's what this means basically. Or you can say, what is the output when input x equal to a? Therefore, this symbol looks much easier for mathematician, also like a mathematical educator. So we're using functional notation easily. Another reason to use functional notation, because we can separate or distinguish many different functions using different functional notation. If all the functions indicate maybe like this, and then y equal to maybe 3x cubed plus 2x minus 1, like that, then all these functions are defined as y. So if I ask you, okay, look at the y, then you may wonder which one, right? However, if I indicate fx equal to 2x plus 1, gx equal to x squared plus 4x plus 5, hx equal to 3x cubed plus 2x minus 1, and based on this, if I call, okay, look at gx, then which function are you going to look at? Yes, you only look at gx equal to x squared plus 4x plus 5 automatically, because that is indicated by gx, right? Therefore, the functional notation widely used for all mathematics topic, also mathematicians, because it indicates easier notation and also to analyze and evaluate different functions. Then now, think about the functional notation and then find the slope. So I'm going to go back before this graph. So at this point we can indicate x1, y1. This one was x2, y2 here, right? Therefore, you can find slope m equal to y2 minus y1 over x2 minus x1. Correct? Yes. Okay, then can you rewrite this using the functional notation? Please pause this video for a second and think about it, and then come back to this video. If you think this way, you have right idea. As I told you, y can be indicated by fx, but you also remember that inside value must be input value. As you know, these are our input value. Therefore, the functional notation must contain this value inside of parentheses here. So those points can be indicated by x1, fx1, x2, fx2. Alright, then using this formula, let's find the slope again. Then slope m will be fx2 minus fx1 over x2 minus x1, right? Okay, now I'm gonna generate a little bit more different notation here. So to make you understand easily, I will give you some point. Let's say x1 and y1, just say 2, 5, and x2 and y2 is 4, 9, like this. But don't try to find the slope, because this is just an example, so we're not actually using this point. Now, can you find difference between 2 and 4? Yes, it is 2, right? Then can you rewrite this one? 2 and 2 plus 2? Yeah, so 4 can be rewritten as 2 plus 2, right? And their interval is 2, so you can rewrite this 2 plus 2. Then now, this one case. 5, you can rewrite f2, and this one is f2 plus 2. So this is the x1, this is the y1, this is x2, and that's y2. Now, in this particular case, difference between two x's will be 2, but it can be any number. If x2 equals 3, then their difference becomes 1. x2 equals 5, then difference becomes 3. Therefore, I'm gonna make this particular 2 as delta x, and this indicate difference between two x's. Make sense? Therefore, I can rewrite this one again. 2 comma f2, and then 2 plus delta x, and then f2 plus delta x. So far so good. Now, the initial x point, the x1 point, I randomly choose x1 equals 2. But as you know, x1 can be any number. What if you choose -1, or 0, or 3, or -5, something like that, right? So x1 also can be any point. So I'm going to rewrite this as x, because it can be varied. So if equal to x here, then this output you can indicate fx. Then this become x plus delta x, and this x plus delta x here. Make sense? I really hope so. I will continue this video for the next video.